You notice that right now you have this really ugly looking fraction that you're trying to simplify? Well, what operation does a fraction mean you're doing? It's division. And so really what this is a division problem. So now treat it as such. Now, every now and then somebody gets a little thrown off here, so just a few more steps along the way. When you see that negative out in front of the fraction, that means either the top or the bottom is negative. I tend to put it in the top just as a matter of habit because it works with everything else as well. And so then you can go ahead and do the fraction division. All right, now that I've put the negatives into the fractions, I can go ahead and do the division part. Now, as you may recall, our work that we do for doing fraction division is that we flip the second fraction and change the division and multiplication all at one step. In other words, we're going to multiply by the reciprocal. Now that I've done that, I can go ahead and multiply the fractions. Now remember, when multiplying fractions, you go straight across the top and straight across the bottom. And so the negative 1 times 2 on the top gives us negative 2 over 2 times negative root 3 gives us a negative 2 root 3. Now looking at that, notice it can simplify. It can reduce a little bit because I have a negative in both top and bottom, and I have a 2 in both top and bottom. So I'm going to divide top and bottom of this fraction by a negative 2. That gives me 1 over root 3, which is technically correct, but not completely simplified. Because, remember we got this obscure rule that we've had to actually use a bit more this year than we ever would have before, that we cannot leave a radical in the denominator of a fraction. For it to be simplified, we need to get that out of there. Now, do you remember how we get the radical out of the denominator? Yep, we multiply top and bottom of that fraction by that radical. So in this case, I'm multiplying top and bottom of the fraction by the square root of 3. The whole reason for that is because on the bottom here, root 3 times root 3, that's the square root of 9, which is 3. And of course on the top, 1 times root 3 is just root 3, so we end up getting the square root of 3 over 3, and that now is as good as it gets. That cannot be simplified any further. That's our final simplified answer for this. Make sure you have all that work written down because you're going to find it ends up being particularly relevant here in just a little while. So this is our completed table from what we did yesterday. Now make sure that all the values are correct because we're going to be building off of those here shortly. Because yesterday was all about sine and cosine going around the whole circle. Today we're going to be adding into the whole thing the tangent values. And actually one other thing that we'll get into after that. So we're going to be filling in some more of this table. Now in order to see how to get those other values, we're going to start with a couple representative values. We're going to find the value of tangent of 135 degrees and the value of tangent of 210 degrees. Now right now, you don't necessarily have any good tools for doing it. So we're going to start by building in some of those tools and showing you how we would actually go about figuring out tangent on the unit circle. So this is our general unit circle picture that we can go back to. And so normally we go from whatever our angle is, and we have our opposite and our adjacent sides. Now you remember the definition of tangent, right? Tangent is the opposite over the adjacent. But remember that we also found there was another way that we could calculate the opposite and the adjacent. For instance, how do we calculate the opposite? Remember the opposite is that y value, so it is sine. And the adjacent, that's cosine. And those gave us those side lengths. And so if tangent equals the opposite over the adjacent, that means tangent could also be found by doing sine divided by cosine. And this works in our unit circle, and we could actually go through and prove it, but I figure you probably aren't too worried about seeing the whole proof right now. This not only works in the unit circle, but it works in any circle. Tangent can always be found by doing sine over cosine. I suggest you make note of that tan equals sine over cosine, and then we're going to start seeing how we can then use that to find those values we were just looking at. All right, so if tangent is sine over cosine, that then gives us tools that we can use to figure out these two values, the tangent of 135 and the tangent of 210. Now I'm going to start with the tangent of 135 here. Now going back to my table, I can find out what the sine and the cosine of 135 degrees are. Hence why our table needs to be accurate, because we're going to be using it to find our tangent values. So the sine is root 2 over 2. The cosine is negative root 2 over 2. So that's how I'm going to find the tangent. Do root 2 over 2 over a negative root 2 over 2. Now, of course, that means we're doing division with it. And I could go through the whole big long process of flipping the second fraction and multiplying it and simplifying from there, but we can actually get there a lot faster here. Because notice this root 2 over 2 and the negative root 2 over 2. They're basically like the same number. The only difference is that one's positive, one's negative. I'm going to pull out a few random numbers here. What's 5 divided by negative 5? Negative 1. What's 7 divided by negative 7? Negative 1. What's root 2 over 2 divided by a negative root 2 over 2? It's also a negative 1. Because it's the same thing being divided by itself, it's just that a positive divided by a negative gives us a negative 1 instead of just a positive 1. And so that is actually the value of the tangent of 135 degrees. Next up, we can tackle the tangent of 210. So that means on my table, I go over to 210 degrees so I can see what the sine and the cosine values are. So the sine of 210 is a negative 1/2. The cosine of 210 degrees is a negative root 3 over 2. So to find that tangent, I'm going to have to do a negative 1/2 divided by negative root 3 over 2. Now this hopefully seems a little familiar, right? I hope it does. Isn't this the problem that we did at the very start of this lesson? Which then makes our lives a lot easier because we don't need to do all that work again because we already did it. So I know in order to divide this, I'm going to flip and multiply, and then I'm going to simplify. It gives me that 1 over root 3. And just like before, I don't want to leave the radical in the denominator, so it gives me root 3 over 3. That is our value of tangent of 210 degrees. Now that we've seen how to get these two values, you now know how to find tangent. And I've given you actually the trickiest type of scenario with finding that one. So your job now is to find all of the rest of the tangent values and fill them in our table. Now you don't actually need to do all that many calculations if you notice the patterns. So it shouldn't take too long. Go ahead and fill that in now. So when we did the tangent of 210 together, we did a 1/2 divided by a root 3 over 2, and that gave us the root 3 over 3. The nice part about that is that anywhere where it's going to be 1/2 over the root 3 over 2 now, you can know that you're going to be getting a root 3 over 3. The only question is positive or negative for each of those. So that just saves you a lot of work there. Anywhere where we have root 2 over 2 over root 2 over 2, that's always going to be a 1 or a negative 1. Because remember we did tangent of 135, the work we did there. Anything divided by itself is 1. But then what about this root 3 over 2 divided by 1/2? Because that one comes up 4 times, and again, it's going to be the same answer. It's just going to be a question of if it's positive or negative. So let's take a quick look at the work you would do to get that. So root 3 over 2, we're dividing that by 1/2. And so that's going to be the same as root 3 over 2 times 2 over 1, which gives me 2 root 3 over 2, which if we reduce it, just equals the square root of 3. So any of those that have the root 3 over 2 on top and the 1/2 on the bottom, we get a root 3. Question is just positive or negative. When your table is complete, this is what you should be looking at. Now you notice a couple of them have those big X's through them. That's because those are undefined. There is no value there. If you write undefined there, that's perfectly fine. Go ahead and check each of those answers, make sure they're all solid. All right, and then once you have all this down correctly, it's time to take some notes, because we're going to shift gears a little bit. And there's actually a little bit more we're going to be able to fill in this big table. But we need to see a little bit of work before then. So, into your notes, please add the definition of a radian measure. So there's a lot of information up in here about what a radian is, or at least what the radian measure of an angle is. The basic idea of radians is that it's a way of measuring an angle by the arc length that it traces out in the unit circle. That's why it's 2 pi radians for a full circle, because the length of the arc around the whole circle is just the circumference. Circumference is 2 pi r, and in the unit circle, r is 1. So there's 2 pi radians in the whole circle. Now, because it's dealing with pi, a single radian, people often ask me, what does 1 radian mean? It means nothing in particular. Speaking in terms of what 2 pi radian means, or what pi radians means, that means something more. But a single pi is some arbitrary little angle that has no particular significance, at least not any that we're going to need to worry about. All right, and then the most important thing, at least at the moment, is how do we convert between degrees and radians? Because they're just different ways of measuring angles, different units. It's like feet and meters. They're just different units for measuring angles. But we do need to know how to convert between them, and that's this formula here. Make sure it's correctly written on your paper and easy to find later, because you'll be coming back to it a lot. It is d over 360 equals r over 2 pi. D is degrees, r is radians in this formula. You'll be converting both ways, from degrees to radians and from radians to degrees. So whichever one you know, you plug it in for either d or r, depending on if you know the degrees or if you know the radians. So let's actually see how we can put this into use then. We're going to convert each of these into the other. So we're going to start by converting 135 degrees into radians, and then we're going to convert 7 pi over 4 radians into degrees. Write down the 135 first, we'll work through it, then we'll go on to the other. So for the 135 degrees, I'm going to convert it into radians. By the way, how do you know that it's in degrees at the start? Is because of the degree symbol. If there is no degree symbol written, then it's in radians. All right, so I'm going to use that formula. It's d over 360 equals r over 2 pi. Now in this problem, I'm given 135 degrees. So I put the 135 in place of the d, which means I'm trying to figure out what r is. And so that's my original setup. It's a proportion. And so in order to solve this, I'm now going to cross multiply. So first up, 135 times 2 pi. Well, what's 135 times 2? That's 270. Now, I don't want you plugging pi into your calculator at this point. In fact, we're going to leave pi in there as pi. Now, I know it does represent an actual number, but it's more accurate just to leave it written in terms of pi. And then we go the other way, 360 times r, which gives us 360r. Now, I still need to figure out what r is, but now I know what to do to get it. Because if I have 360 times r, I need to divide both sides by the 360. So I divide both sides by 360, and on the left side then I have 270 pi over 360, and then that equals r, because I divided out the 360, remember. Now, in this case, we do have one more step. We've done the right stuff here, but our answer, it can reduce. So I'm going to reduce my fraction. Now, the pi on top is going to stay a pi on the top. Now I just need to reduce 270 over 360. So Well, they both end in zeros. That makes my life a little easier. I can divide them both by 10. That would give me 27 over 36. What can I divide both 27 and 36 by? 9. Yeah, let's divide them both by 9 then. So if I divide them both by 9, that gives me a 3 and a 4. Can that reduce at all? No. So then, when it's reduced then, I must get 3 pi over 4. That then, now that it's reduced, is our final answer. Now on to the 7 pi over 4. Again, my setup is the same. I'm still going to start with d over 360 equals r over 2 pi. In this case, I know the 7 pi over 4, that's my radians, so that's going to go in place of the r. So I go 7 pi over 4 on the top of that fraction. I do not know d. That's what I'm trying to find, so it stays a d. This is usually the point when people start freaking out a little bit, because they see this and they think that it's big and scary. But deal with it just like any other number. So my next step, I'm going to go ahead and cross multiply. So I'm going to do 360 times 7 pi over 4. Well, that means I can do 360 times 7 divided by 4. Now this is probably a spot where you would probably want your calculator. You don't strictly need it. There's ways to do it without it. Let's go ahead and do that. 360 times 7 divided by 4. And that gives us what? 630. Now, the pi that was in there, it is still there. So it's actually 630 pi. And then I cross multiply the other way, which gives me 2 pi d. All right, next up, I still want to get d by itself. Now notice what's in the way of d being by itself. It's being multiplied by 2 pi. So I'm now going to divide both sides by that 2 pi. So on the left then, that's 630 pi over 2 pi. And on the right side, that just now equals d, because again, I divided both sides by 2 pi. Now notice what we can do in terms of simplifying that. On that fraction on the left side, the pi's are just going to cancel out. That's one of the beautiful things about leaving the pi in there and not calculating it as a decimal. If you had decimals here, you probably wouldn't see that we could cancel pi out. So that just leaves us with 630 over 2. So, okay, what's 630 divided by 2? 315. That is 315. So my final answer then is 315 degrees. I do want to include the units in my final answer because I do know this represents degrees, so we want to include the units for degrees to show that it is. All right, now that we did these two examples together, it's time for you to apply this on your own. I would like you to please convert each of these degrees into radians and each of the radians into degrees. All right, so first up for the 780 then, we do 780 over 360, because we always put the degrees over degrees, equals the r over 2 pi. Now that we have that set up, we go ahead and cross multiply. That gives me 1560 pi equals 360r. And then we divide both sides by the 360. And now that we have it written as a fraction, we just reduce that fraction. And then that reduces down to be 13 pi over 3. Then for the second one, the 11 pi over 6, we start the same way. In this case, it's going to be d over 360 equals 11 pi over 6 all over 2 pi. And when cross multiplying, remember you're multiplying that 11 pi over 6 by the 360. So when we do that cross multiplication, 11 times 360 divided by 6 gives me 66. So it's going to be 66 pi. I'm sorry, I forgot a 0 there. 660 pi equals 2 pi d. And then we divide both sides by 2 pi. 660 divided by 2 gives me 330. Pi's cancel out. So d equals 330 degrees. Now on to the second set out of that first set that I gave you. Here's our original setup for each one. So I put the 15 in for d in the first, and the second I put the pi over 60 in for r. Now for each of those I'm going to cross multiply. I'm going to go ahead and finish out the first one, then we'll do the second one. So I'm going to cross multiply here. So 15 times 2 pi gives me 30 pi. And then that equals 360r. So then I divide both sides by 360. I'm going to write it as 30 pi over 360 first. It makes our reducing process more reliable. And then when I reduce that, that gives me just 1 pi on the top. I don't need to write the 1 because I got the pi on there. And then on the bottom, I'm left with 12. So 15 degrees equals pi over 12 in radians. All right, now on to the second one. Again, I cross multiply. I'm going to do the 360 times the pi over 60. You know this is actually mental math for most of you? Because I'm doing 360 times pi, and then I'm dividing it by 60. Well, 360 divided by 60 is the same as 36 divided by 6, which is 6. So it's 6 pi equals 2 pi d. Then we go ahead and we divide both sides by the 2 pi, which leaves me with 3 equals d, so it equals 3 degrees. Anytime it's d equals, make sure to include the degree symbol there with it. All right, so next up, you're going to get lots of practice doing these conversions because we are now going to complete that trig table. That top gap has been left for the radian measure. So please find the radian equivalent for every single one of those angles.